Okay, let's get started. I'm Kurt Brown. I manage the data platform team at Netflix. And today we're going to talk about the architecture of the data platform, a bit about our philosophy, and then we're going to do a deep dive into Mantis, which is a reactive stream processing system that we're building at Netflix. And Justin Becker is going to take over and talk about that. So first I want to start with what's different at Netflix than most places. So some of you might be using some of this stuff. I saw in the keynote everyone was sort of bashing the cloud. That's one of the big things that's different about Netflix. So let's dive into those. So the biggest thing is virtually all of our infrastructure is in the AWS cloud. So we were in the data center way back when, but almost nothing is there. By the end of the year, we expect nothing to be left in the data center. That includes our billing systems, our analytics systems, et cetera. So it's a big differentiator versus a lot of really at-scale companies, and we're an at-scale company as well, not as big a differentiator versus some smaller startups. Another big difference versus a lot of big data analytics companies is that we use S3 as our central data hub. So a lot of people either have their own remote object store or file store, or they use HDFS very heavily. We actually don't use HDFS all that heavily. It's part of the plumbing of some of our jobs, but it's not our persistent storage layer for Hadoop. We also use EMR for Hadoop, so we've looked at all the distributions, Cloudera, MapR, Hortonworks, rolling our own. But at the end of the day, since we're in Amazon and we have a good relationship with the EMR team, Elastic MapReduce, it's worked really well partnering with them. So tying into the fabric of Amazon, having a good relationship, and it gives us things like, one thing we negotiated is a site license with them, which is now publicly available, and that gives us a lot of great capabilities. Like, we don't have to think about cost, which we had to think about before if we went with a vendor and they try to charge us by node, and then there's the elasticity of Amazon, and we just don't have to worry about it. We've already pre-reserved a lot of hardware. We just use it. We don't have to worry about any costs at this point. And then the other thing which gets into the philosophy section is freedom and responsibility. And I'll dive pretty deep into this, but it's a little different culture at Netflix. What we try to do is really enable someone to do whatever they want to do to a certain degree. We want you to act in Netflix's best interest, and then you're responsible for your actions. So it's just expecting a level of maturity on the part of developers, and then the benefits you get out of it is you don't have so much process and rules to put up with along the way. So first, diving into architecture, I want to show you way back, circa 2009. This is what our BI stack looked like. It looks a bit like a banking stack if you are in BI, and that's because we had a couple of bankers that came in and started our BI group. Needless to say, they're not at Netflix anymore, and our stack looks very, very different at this point. So what does it look like today? So the first thing is S3, as I said, is our central data hub. That's where all the data is going in and out of. It's sort of the plumbing and the fabric that glues everything together. The first part of it is our massive event pipeline, sort of like the Scribe or a Flume that a lot of you guys might be using. It's called Suro. It's open sourced. It processes about 350 billion events per day. That's things like video quality, what are people searching for, UI, interactions, and the like. And it's a pretty nifty little pipeline. You basically just throw some key value pairs in there. You can annotate the object, and then if a Hive table doesn't exist, it'll automatically create it for you. It'll put all those key value pairs in a map field within Hive, or you can config something and blow it out into first-class columns. So you don't have to think a whole lot about it. You just log it, and then it's available, again, like a lot of technologies you guys are using. Now, that covers the event part of the pipeline, but what about the dimension part of the pipeline? So you saw Oracle in the previous picture, very little of that left in our infrastructure at this point. And Cassandra's worked really well for Netflix. It scales very, very well. It spans multiple data centers, very fast reads, very fast writes. So it's great for everything except for what my group does. It was a real pain in the ass, actually, for what my group does. And what that is we need to get all the data out. We need to get the data into S3 because we want to join it with all this rich event data, do our analytics. And when we initially talked with Cassandra folks, they're like, oh, just do the analytics in Cassandra. It's like, oh, that's well and good, but we have 350 billion events, not that many at the time, that we need to join together with this stuff. So we need to get the data out. So a couple engineers on my team, at the end of the day, we're like, we don't really care about Cassandra for getting the data out. We just want the data. So we have an open source tool called Priam, which automatically backs up the SS tables underlying Cassandra, puts it on S3. We load it up in a Hadoop cluster. We take the 3 copies of the data in Cassandra, crunch it together, take the most recent timestamp, re-persist it in JSON format on S3, and now our ETL developers have something they can work with. They don't have to worry about any of the idiosyncrasies of Cassandra. And what do they do with it? Then they use Pig and Python, which is our ETL framework of choice. They can translate any of the data they want, they can filter it, they can aggregate it, they can join it to Suro, and then they can repersist that data back in S3 so that analytics can happen quickly. Hive is a big part of the mix. It was actually predated Pig in our infrastructure. So this is where most of our engineers will do their querying. It's slow, as you guys well know. So that's not all well and good. And that led to Presto. So we released this into our environment about 6 months ago, and it has been awesome for us. So we worked pretty closely with Facebook on this, contributing back and partnering on things like ODBC drivers and Parquet format, and working with S3 was a big thing for us, obviously, since it's not something Facebook had to deal with, but something we had to deal with. Now, despite these great cloud technologies, we do have some traditional data warehouse type databases in our mix. Teradata, you can see the little cloud around it. So we had it in our data center. We wanted to be out of the data center, and we pioneered with Teradata a cloud offering on their part. So we were the first. So it's not full-scale cloud for what we're using, but they're getting better and better at the cloud, which might lead to, well, what about Redshift? If we're in Amazon, why aren't we using Redshift? We actually are using Redshift quite a bit. So that's another big data analytic database. We're using it for a third-party CS application where we don't want to commingle our backends and somehow have some way that they could get into Teradata and see some data. Even though we don't put PII data in there, we just don't want our third parties to be able to get at our really rich sources of data. And also our engineers and our algorithms teams will use Redshift to do kind of scratchpad type work, like join data together. And we're hoping over time that the race between Redshift and Teradata continues and they get better and better and better, and we have this sort of hybrid environment that you see. So where does it go from here? It feeds into MicroStrategy, so that's still part of our mix. That's our enterprise reporting tool. So most of our daily dashboards and our email reports come out of MicroStrategy. More recently, Tableau has gained a foothold. A lot of people like that. It's very easy to get started. You don't have the heaviness of MicroStrategy, but then you also lack things like the rich metadata layer. So there's a lot of trade-offs along the way. And recently, partnering with Facebook, we also got ODBC driver working between Presto and Tableau. So we're using that internally now. And then lastly, we have one other reporting tool called Sting. So you can see we have a whole suite right here. And this was in response to a lot of teams within Netflix were starting to build their own reporting layers on top of our big data warehouse, so on top of Hive in many cases. And it just felt very inefficient. So my team said, OK, let's just build something with a service-oriented architecture. You can throw your own UI on top if you want. And what it lets you do is take the results of a Hive query, load it in a memory, slice and dice it, filter it. So one theme you can see from all these technologies is that, from Netflix's perspective, hybrid is really the way to go. Like a lot of companies say, I'm just going to use Hive for everything. Like your users are going to kill you if you do that from a performance perspective. Or a lot of times people say, I just want to use one reporting tool, which can make sense if you can get away with it. Like less is definitely better. But if there's something really differentiating that you need to drive your business, then you need a hybrid environment. So you saw we have MicroStrategy, we have Tableau, we have Sting. They all serve different purposes. There's an expense to maintaining those, but they help drive our business forward. And then the data store, even more so. We have Presto, we have Hive, we have Teradata, we have Redshift. But again, we've very much rationalized why we're using what we're using things for. Presto, for example, was a no-brainer for us. It shares the same metadata as Hive, shares the same data as Hive for us, especially since S3 is our backend. So it's a very, very low-cost system for us with performance in the 10x to 50x type range. So as I mentioned, S3 is our central data hub. Data is going in and out all the time. But to really take advantage of it, or actually first, I guess, why would we do it? So some of the great things about S3 are durability. So you get 11 nines of durability. It's a lot better than you're going to get in your data center for the most part. And it's very, very scaled out as well. So you can actually get performance benefits in some cases using S3. We also have the ability to undo changes. So we used version buckets within S3. So if someone deletes something by accident, we can undo it. So that happens every so often. But really, to get the advantage out of S3, you need to sort of abstract the people away from it. And to take advantage of this rich, elastic ecosystem, in Amazon and EMR, we created something called Genie. And what this is APIs that you can interact through, and you don't have to worry about what are all the resources behind the scenes. Like, what Hadoop cluster is running? Is it there anymore? Is it going away? Am I expanding it? Am I shrinking it? Am I doing a red-black push? So where Genie comes in is this is what you interact with as a developer. You say, I'm going to submit my job through Genie, and it's going to take care of things behind the scenes. And it's hopefully relevant to you guys because it is open sourced. We actually internally just launched Genie 2, which is a more generalized execution framework. So instead of just being Hadoop, it can execute against any backend framework. So who knows what it will be used for in the future, Mesos or with Spark, or we'll figure it out as we go. But what does it do for you? So here's a classic example. Swap out S3 for HDFS, perhaps in your environment. You have Hadoop running, everything's well and good, and then badness strikes. So your Hadoop cluster stops performing, something's really wrong, oh crap, your data's in HDFS, you can't just get rid of your cluster. So there's a lot of scrambling. For us, this is the scrambling that we do. We just spin up another cluster, and then we kill our old cluster. If the old cluster is sort of on its last legs but hasn't completely died, then we'll keep it running, let the long-running jobs finish, and then when those are done, then we'll spin the cluster down. In the meantime, all new jobs are going to this new cluster. And then the same paradigm could be, as I mentioned before, red-black pushes. Whenever we're doing an upgrade, spin up a new cluster, let the old jobs finish on the old cluster, and then you go on your merry way with this new cluster. Taking this further, we don't have to do it just for red-black pushes or when there's problems. We can also do it for just our daily operations. So our nightly batch processing, our real production-heavy jobs, they run on our high SLA cluster, and then the sort of cowboy, ad hoc, whatever you want to do, that's on our query cluster. So the nice thing is they're sharing the same data in S3, and we can have as many clusters as we want. We don't have to worry about contention on HDFS or, in theory, the priority schedulers could handle more efficient use, but they're just not that good in many cases. So this gives us de facto isolation between our SLA jobs and our query jobs. So another nice benefit being in Amazon is that we have something we call bonus clusters as well. So I mentioned before that we have an EMR site license, so we don't have any additional expense for that. We've got pre-reserved a ton of hardware because we're streaming videos all the time, but people go to sleep at a certain point, thank God. And we can use that hardware. So and at night, when a lot of our batch jobs need some hardware, we've got a lot of hardware sitting around at Netflix that we've already paid for. Most people at Amazon actually reserve 24/7 at a certain scale. It's not as elastic as people think, or it can be, but it's expensive to be. So we just borrow that hardware, and then we spin up 3 bonus clusters in different availability zones or data centers, and then we just churn through our batch jobs, and then when we have to give it back to production, we give those machines back, and then they continue using them. And if, the nice thing about Genie is if we have to give those machines back before we're ready, we can just repoint, even though someone pointed their job at a bonus cluster, we repoint it at the high SLA cluster, and then any new jobs will run there. Harder to do if you've got it like hard-coded, pushed to one particular cluster. Now, it's not all peaches and roses, unfortunately. So S3 does have eventual consistency to deal with, just part of the CAP theorem, something to deal with. And we struggled with it for a while. The worst part about it is it doesn't happen very often, but it creates a crisis of confidence in your users in some cases. Like, hey, I know I put the data there, and my next job try to read it, and it's not there. I just don't trust anything anymore. So after some clever engineering work, some folks on my team came up with something called Semper, which uses aspect-oriented programming to basically wrap the calls to the file system. So whenever something is written to S3 or read from S3, we also write to a consistent index store. So we're currently using DynamoDB, but we could use anything. And then in addition to, hey, I'm checking is that data in S3, it also checks against Dynamo's index and says, is it there? And if it is in Dynamo and it's not in S3, then you know that there's some eventual consistency. So it hasn't caught up. Or maybe it's been deleted, but it hasn't fully disappeared from the index in S3. So what this lets us do is have a fully configurable system where we say, hey, if we see these inconsistencies, we can just wait. And by default, we wait for 15 minutes. We can fail the job after 15 minutes, or we can say, go on your merry way. The developer has total control for every job, how they want to deal with eventual consistency. And at a certain point, we just say, OK, trust S3. We don't use this consistent index forever. It should catch up at some point. But it's been a really nice shim layer that lets us trust our data more. And this is open source as well if you're using Amazon. So that's what we're doing now. But what's in the works? So faster and easier, those are always themes that people know and love. So some cool things we got in the works right now. Hadoop 2, we recently upgraded to. I imagine some of you guys have as well. Again, not all warm and fuzzies there, but we got it working, dealt with a bunch of bugs, worked with Amazon, put some patches back into open source. And it does, in and of itself, it doesn't give you huge performance improvements, but it gives you flexibility, like better control of memory and the like for MapReduce jobs. But it is a foundation that you can build on top of. So some of the other projects are Parquet. Since we use Pig and Hive so heavily, we're not using org files right now. But this is a columnar format, great compression, a rich ecosystem around it. And we've done a fair bit of work, especially getting it working with S3 and with Presto. And I mentioned Presto before. We've been really happy with it. Whenever I hear someone says they're just going to use Hive for all their data warehousing, I'm like, oh my gosh, your users are going to revolt, and they should. But if you throw in something like Presto or Vertic or Teradata or something else to sort of ease the pain for the quick queries or for the reporting tools, then it can go really far. So we haven't moved fully to Presto. We still are using traditional databases, but it'll be interesting to see how the ecosystem develops over time. Pig on Taze, we did quite a bit of contribution to Pig on Taze. The only problem we hit is that we kind of got ahead of Taze, or Tez, depending on your pronunciation, because a lot of the backend stats are just not available. So we got to the point where our developers were getting frustrated because they didn't have the visibility they had in MapReduce 1, Hadoop 1 with Pig. So we put it on pause for now to let Tez catch up. And then we might resume in the future finishing the work on Pig on Tez. And then Spark, we looked at it in 2013. We could tip it over by blowing on it at the time. So didn't work at any sort of scale or multi-tenancy, but obviously the community has exploded since then. Databricks broke out into its own company. So we're quite interested to see where this goes, and we're investigating putting it back in our stack. The various teams at Netflix are looking at it for stream processing, for machine learning, and then for batch analytics. On the easier front, we have a lot of open source tools out right now. This is a new one called Invis, which will be open source in the next couple days or next couple weeks. And what this does is it uses Elasticsearch to capture all of your data about your Hadoop ecosystem and very easily search on it or visualize and see performance issues and just how everything's going without having to track through all these logs all over the place, which is particularly challenging somewhere like Netflix, where we have machines that disappear after certain periods of time. So we need to capture that rich metadata somewhere so that we can use it whenever we need it. So here, I search for a particular job. You see when job started, finished, the clusters they're running on, the Genie name, and there's a Genie ID that you can link to. And from that, you can get really rich data about what's happening in your MapReduce jobs. So at the top, you see sort of a swim lane where it shows the parallelization of your job. So all in one view, this is the layout of a particular pig job, how it's playing out over time. And then below it, you can see each task, how it's operating, along with rich counters. And it's just all consolidated in one place. And you can see things like, oh, maybe there's a big skew on a particular task, or there's a flaky machine, or the like. So it's basically just bringing it all together. So look for a tech blog coming out soon, and then you're welcome to try it. It should be really easy to install it in your environment. Another benefit of it is it shows cluster utilization. So I highlighted one particular user. You can see how much of the cluster they're using, and you can see in the bottom our backlog over time on our Hadoop infrastructure. So this helps us if someone says, oh, I can't get resources, we can very easily see, is it because of when you were running it? Maybe you can run this backfill job at a different time and use our resources more efficiently. So next is on the easier front. We are putting out something called a Big Data API, otherwise known as Kregel. So Kregel is from the Lego movie, if you've seen it, where they glue everything together, which is kind of antithetical to an API. But it's trying to be about cohesion is the theme here. And we have tons of tools, and they are all custom written in their own way. Some are open source. Franklin is our metadata store. Agassiz to get data out of Cassandra. Charlotte, dependency analysis, transport moving data. Lipstick is for our Pig workflows, visualization and monitoring, and then et cetera, et cetera, et cetera. But what the Big Data API does is a common sort of syntax in Python that anyone can use. We're going to build all of our tools on top of this, and very easily you can just, for example, run your Hive job, specify it here, get the details of your job, see the results, all programmatically. So within my team, the data platform team, we can build on top of it, or anyone within data science or algorithms teams at Netflix can use this. So they're still early stages. Here's another example where it's interacting with Franklin code here, and then it's using Transporter to move the data from Franklin into Hive tables. So you can look at the slides online afterwards if you're like, I want to see that code. And then the culmination of this is going to be the big data portal. The first rev of it is very, very simple. It's just a query interface on top of Hive. Presto will be added to the mix. But the goal here is not just to be a query interface. It's like this is where you go. If you're in data science and engineering, you want to know what's happening in your cluster, just go here. You'll be able to query your data. You'll be able to see rich information about the cluster. Anything that's sort of top level, I just want to know what's happening, you go to this big data portal, and then we'll link off to our individual tools that are written on top of the big data API if you want to do deeper dives. So this is a pretty exciting project that we're really excited to see where it goes within Netflix. So have a few minutes left. I'm going to burn through philosophy very, very fast. So how do we do what we do within Netflix? And I'm sure some of you guys do a lot of these things as well. If not, you might have some neat things you can take back to your companies. So one of my favorites is the Netflix expense policy. This is it, 5 words: act in Netflix's best interests. So it's, why do I care about expense policy in a presentation like this? Really, it's a North Star, I would say, within Netflix, is that it's like, do what makes sense for Netflix. So we don't need to say, you could spend $400 in a hotel and you can't fly first class or business class. It's like, just do what makes sense. Like if you're going to do a long business trip and you really need to work and you really need to fly business class to Europe, that's freedom and responsibility. That's your judgment call at the end of the day. But it's mostly like, would you do that if it was on your own dime? And if you would, then all power to you. But at least this way, we don't have to add a lot of rules and process. Another is our development and deployment flow. So instead of having lots of nasty gates along the way, and you have to go give the code to a DBA and they have to release it, instead our flow is best practices up front, make sure everyone's clear on those, have components, consultation, tools, and automation to sort of have the rails that your release process goes on so people are doing things consistently. And then the big price we pay is on the cleanup. So we let people get code out really quickly, and then we have to go and clean it up in many cases because things will build up technical debt and cruft over time. I mentioned DBAs. I have one DBA in my team, and I'm in charge of the data platform. And he doesn't do mostly DBA stuff. It's more performance type stuff and database expert. And the reason is that he doesn't release code. There's no point. I mean, like, I hate in companies where you give the DBA some code, they release it to production, they add no value in most cases. There are exceptions in some places. But if it's just releasing code to production versus optimizing it, what value does it add? So instead, we have a tool called Being John Malkovich, a lot of movie themes in Netflix, where you can flip yourself from a readable to a writable mode in the database world and say, hey, normally I want to be in read-only mode. I don't want to accidentally truncate lots of tables, but I can just flip myself into a writable mode, and then I can do whatever I want, and then I can flip myself back into readable mode later on. Or if I forget, it'll automatically revert me after, I think it's like 5 hours. A QA team, this varies within Netflix. Like if it's production-facing, user-facing, there's going to be a little more QA within data platform. We can be a lot more flexible. So we don't have a QA team. We don't have a process where you say you have to get everything reviewed. Freedom and responsibility. If it's a complex change, find one of your peers, have them review it. If it's simple, just release it. Upgrading is in a similar vein. If we're upgrading from one version of Hive to another, we'll do a baseline amount of testing, but we won't test it to the hilt for months and months and months and not catch everything anyway. We'll, at a certain point, say, well, let's release it. We've done some baseline testing. We gave people an environment. They can test their stuff themselves. And then we'll do some firefighting on the day of release. And we expect that's going to happen. And part of that is accepting that things are going to break when you do that. Like you can't just say, oh, we're not going to fully test it, and then you beat someone up when it breaks. You say, well, I know a few things are going to break. You still expect good code from people, but you expect a few things are going to break, and then you recover quickly, as opposed to hold up the launch for a couple extra months and still not catch 90% of those bugs. Safety nets are really important. I said version buckets for S3 was one thing we do. We use backups of our databases. So there's a lot of ways that we can recover quickly. We can use that red-black push to an older version of the cluster. Another neat thing is we have vending machines at Netflix that you can get any hardware you want out of there. Actually has prices on it, but it doesn't cost anything. Really, that's just context to say, this is what it costs. If you think it's worth it, then and you should just push the button and get your power cord or get whatever you want. So, and it's the same thing like MicroStrategy licenses. Like if you log into MicroStrategy, it automatically creates one for you. You don't have to go through lots of processes and tickets. If you need it, you know you need it. Rules and processes, as I said, eliminate it whenever we can. My first day, people were beating me up at Netflix. I'm like, welcome, welcome, huh? About the release process we had, which used Perforce and Unix scripts and all this stuff. And now I told you we have that Being John Malkovich tool that just lets you release much easier for database stuff. tell versus ask. So if you're in a big company and you say, hey, can I do this? It'll never happen. So instead, we just said, we're going to do this. You either say, don't do it if it's really, really important, or in many cases, we'll just do it anyway, and then we'll revert it if something breaks along the way. So this sting reports that I mentioned before, those are getting loaded in memory all the time. We just send an email out every couple months and say, hey, we're going to expire this report unless you click on this link. And if you click on the link, it stays around, otherwise it goes away. And then, does it really matter is probably another good theme to really think about on your day-to-day. So my last company, I remember like 8 o'clock was this witching hour for getting our batch processing done. Nothing changed if it got done at 8 o'clock or 10 o'clock, and everyone was on call and scrambling and getting yelled at, and it just made no sense. So at the end of the day, it's like, do you want to put all your energy into putting your developers on call, your source systems on call, just to make sure that you prevent anything from breaking or you fix it fast when no one's going to do anything different? Or do you want to let them sleep at night and focus their energy on something important during the day? So the last thing I'm going to cover is just a Netflix culture deck. Do a Google search on it. It's not fluff. It takes some of the themes I said before, and I think it's a quite interesting read on how we do things at Netflix, and again, might be some good principles for you. So with that, I'll turn it over to Justin, who's going to deep dive into Mantis.
Notes? Do you know how to get the notes? Do you know how to get the notes? So can you exit this? I don't know. Oh man, I don't know. Okay, so I'm Justin Becker. I'm an engineer at Netflix. I'm excited to be here to talk about a new system under development at Netflix called Mantis. And so to start the conversation, I want to provide some context about what motivated us to build Mantis. And I like to think that we were motivated or inspired by the traditional television. So one of the things that I think we take for granted is when you get home, at the end of the day, you turn on your television, you press play, your TV just works. At Netflix, for internet television, we want our customers to have the same experience. When they get home, they turn on their Apple TV, their Roku, their Android device, they select the movie, they press play. We want the experience to just work. And so the question we had to answer is, well, does Netflix work? When people get home and they press play, how is their experience? And really, this actually turns out to be a non-trivial problem. Because when you want to answer the question, does Netflix work, you really need to know, does Netflix work for everybody? It's not okay that it works for the majority or the popular devices. We really want to know, does it work for everyone, just like your traditional television? And so to motivate or help kind of provide some context here, let's start with a simple question, a question that Netflix should be able to answer. When you sit down and you press play for House of Cards, does it work? Or if you wanted to get more specific, when you sit down in Canada and press play for House of Cards, does it work? Or even more specific, if you're in Canada, you're watching on a Roku, and you press play, does it work? Or you can continue this logic, in a particular ISP, does it work? In a particular city, does it work? And to generalize, you'd like to be able to answer this question over many dimensions: bitrate, UI version, firmware version, A/B test cell. And really, at the end of the day, we're really interested in answering these sorts of questions for billions of permutations. And by the way, we want to do this automatically and in real time. And so when we thought about what we would need to build in order to answer those types of questions, we realized pretty quickly that we needed to scale our insights capability. And so the name of the system that we put together to help scale our insights capability is Mantis. We like the Mantis shrimp because there's two interesting facts about the Mantis shrimp. It has extremely good vision, and it's able to strike its prey really, really quickly. So we like those two properties of the Mantis shrimp. And so you might be asking yourself, well, why are we building yet another stream processing system? There's Storm, there's Spark, there's SAMZA. And these are all really good systems, and we evaluated those systems. But when we thought about the problem that we were trying to solve, Mantis actually turned out to be solving a unique problem for a particular domain. And that domain is the insights domain. And what I mean by insights is when I think of data and deriving value from that data, insights data is really deriving value and giving you insights into complex systems. And I like to contrast that with the business domain, where I think the value that you're deriving from the data is to make customer insight decisions. So for example, when you launch a new product and you do an A/B test cell, or you're trying to identify customer trends and growth rates. And so when you think about insights problems, there's a set of requirements that are a little bit different from traditional business problems. Insight systems are more cost sensitive. So to give you an example for this, you don't want your insight system to cost more than the system that it is monitoring. Another key requirement difference is you want to prioritize throughput. This may sound a little bit strange when you compare it to these big production systems, but at least at Netflix, for every customer request that we get, that actually creates many insight events or measurements from that customer event. So typically our insight systems need to scale at a factor larger than our customer-facing systems. Another key requirement is we really want to optimize for low latency. So when I was giving you the example about does House of Cards work, it's not enough to know did House of Cards work an hour ago or last week or last month. We want to know does it work now? And we want to be able to answer that question for billions of different permutations. Another key difference is we're okay with tolerating some amount of data loss. As long as we can get a good enough sample, that's all we need to answer these types of questions. And so I want to focus now on how we built Mantis. And because this is the scale conference, I want to emphasize some of these decisions with an emphasis on scale. And so I want to focus on three particular areas: utilization, latency, and throughput. And so for utilization, it's all about maximizing utility for the machines that are running your software. And so for Mantis, we began by designing it for the cloud. And so in the cloud, we get two nice benefits. We get this capability to elastically grow and shrink the infrastructure that Mantis runs on. And we also have the ability to elastically grow and shrink the jobs that are running within our infrastructure. Okay, so how do we achieve low latency? So the way that we think about low latency in terms of Mantis is that everything is asynchronous from top to bottom, starting with our network stack. So we use NetE at the network layer. At the programming layer, we use RX, reactive extensions. And really that gives us the benefit from top to bottom to have an async architecture. And so the next challenge I wanted to talk about is throughput. And throughput is all about pushing data through pipes, right? Really maximizing the amount of information that's flowing through your infrastructure. And so to maximize throughput, we needed to provide an integrated approach to back pressure. And so what back pressure is imagine you have this complex network of pipes. And in one of those pipes, you have a clog. You don't want to just continue to push more and more water through that pipe because you risk bursting it. And so what you tend to do is have an approach where you sort of throttle or limit the amount of water that goes through that pipe until you can unclog it. And so for Mantis, we took similar approaches like that to have an integrated approach to back pressure. And really that's about having a cooperative strategy. And what that means is you start at the network and you look at the network and you say, can the network actually push information to these subsequent stages in my job or my execution flow? And if the network can't keep up, you need to throttle backstream. Another approach is processing back pressure. So within Mantis, we can actually detect that a computation is taking too long, and we can take steps previous to that computation to slow down or sort of limit the amount of information that's flowing through those pipes. And because this is a holistic approach, we can actually inform our scheduler. When we can detect that these back pressure issues are going, we can say, hey, scheduler, you need to provide more resources to this job so that it can scale up to accommodate the amount of information flowing through it. And so now that I've spoken a little bit about Mantis, I wanted to give you guys a feel for what a Mantis job looks like. And so a Mantis job is composed of three abstractions. We have a source, we have one or many stages, and then we have a sink. And a source is all about getting data into your job. and it also provides some basic back pressure strategies. So this is, I'm pulling data into my job, and my job is unable to process that amount of information. What sort of strategy should I take and not just continue to try to push information through that computation? The stage is really the unit of processing. This is where the user of Mantis writes their custom processing logic. This is also our unit of scheduling. So when we're scheduling a job to run in our infrastructure, the stage really dictates how that information gets spread over many machines. The sink is the output to the job. This also has back pressure concerns, because if you imagine many clients connecting into your sink, you need to be concerned about if you have one slow client, it should not affect the entire job. And so I wanted to provide an example of what a job looks like. So I know this is code, and it's hard to read, but I'll try to walk through it here. So the blue information is just the Mantis API itself. And for this particular example, we're sourcing data from Twitter. So we're getting the fire hose, and we're actually filtering it by any tweets that have Netflix in them. And then for each tweet, we run our NLP sentiment analysis to say, are people speaking positively about Netflix? Are they not speaking positively? And then we take that sentiment outcome and we group it. And then in our next stage, all we do is buffer that sentiment by some amount of time and count them. And then we output that information to a graphite graph. And so this is just a real quick example of how you can take the Twitter fire hose, run a sentiment analysis algorithm on it, and then graph the different sentiment outcomes over time. And we do things like this to answer the questions that I presented to you earlier, where it's, I want to track all of the movie failure rates for the entire catalog at Netflix. And so this is what a job would look like in that infrastructure. Okay, so that's a job. Well, what is Mantis itself? So really, Mantis is a fault-tolerant master with fault-tolerant agents. And we have an intelligent scheduler that's managing the work that is done by those agents. And the work that those agents are performing is just operational insight problem. They're trying to solve these operational insights problems using a job abstraction like I showed before. And that's really the end of my presentation. If you guys have any questions, feel free to contact me or Kurt. And I thank you for your time.
Any questions?
Hello. Hello. So I would like to, before we continue Q&A, we had a lot of trouble with the iPad app last time. So I'm going to give an actual demo so we get it right this time. So this is really, really simple. I'm going to go over this again. So there's a red, which means you didn't like the talk, a yellow, which means you moderately liked it, and a green, which meant you really liked it. So just tap once on one of those buttons, and that's all that is needed to give feedback. Thank you.
Hi. So in your presentation, you said you wanted to analyze like different dimensions when a failure occurs, like a ISP or a country or something. And you said there are millions of possible combinations. How do you actually generate those combinations, or how do you come up with those combinations to monitor?
So we don't do ahead of time. So it's really the byproduct of the job that's written. So if you're going to track those permutations in your job, you would need to group by and partition by those partitions that you're most interested in tracking. And so when I think about Mantis jobs, I think of them as really managing billions of streams of information and computing analytic results for those billions of little small streams. So it's really a byproduct of the job. And we don't store any of the information. The information is just flowing through the system, and we're computing those metrics for people.
So Mantis itself doesn't solve the problem of figuring out what dimensions to monitor?
No, it doesn't automatically do that for you. We have a layer that's built on top of Mantis that helps doing anomaly detection and outlier detection and things like that. But at its core, it's really a processing framework to do real-time analysis.
Thank you.
Hi, guys. Thank you. So you guys mentioned you guys use S3 for the backbone for storing most of the data. So how do you guys deal with like the sensitive data that user have? For example, privacy data, you know, like to make sure it's secure and also gain the trust of the user.
Yeah. So for the most part, we just don't store it because it doesn't have enough analytic value, or at least the trade-off in our world is just not worth it. So Cassandra, obviously, it's going to have it because we're serving end-user requests. We have to validate things. but we just keep it out. So it's just a trade-off that we've made, and it lets us run faster and have less controls in place.
So user behavior data, for example, watch movie that you watch, would that consider like sensitive data or non-sensitive?
I mean, I guess from a VPPA perspective, the Video Privacy Protection Act, it potentially could be. So there are lots of controls. I mean, there's security keys and all that stuff. And we don't make it publicly available to anyone outside of Netflix, but we don't have HIPAA data, for example, or credit card data that we store there, or usernames or emails, or we just try to keep all that stuff out because, again, we've just made that sort of cost-benefit trade-off. And if someone had to do some really custom analysis, we would take it out of Cassandra, put it in some side system, and do the analytics there. And I think that lets us run faster.
Thank you.
So kind of a follow-up for the previous question. So it means anybody who wants to analyze data using Mantis has to know beforehand what dimensions they want to slice or dice the data on, or are there tools built on once you have processed the data, can you still slice and dice in different ways?
Yes, so the way that Mantis works is you have a Mantis job, and a Mantis job can have parameters. So you could specify, it's not so much that you know ahead of time what you want to track, but you need to know the general structure of the data that you're analyzing. And then at runtime, when you submit that job, you can actually inject parameters into that so that it specifies what of those things you want to be tracking. I don't know if it's definitely not an a priori ahead of time, like instrument your code and the metrics will flow into this data store. It's very much, I'm going to write this job right now, submit it into the infrastructure, and then when I submit it, that analytics flow starts to happen and I get the output of that.
So at the time I submit the job, I do have to know
Sure. So an example would be, we get a customer, CS calls and says, hey, we just did a release in France, and we're getting some calls saying, people can't start play on this particular device. At that moment, then we would launch a job that basically is tracking that device over many dimensions, giving us insight into what's going on.
All right. Thank you.
Thanks for the talk. Which throttling mechanisms have you found best reduces back pressure? Is it decreasing sample rate or sample size or narrowing?
It's really use case by use case, analysis. We tend to have queues, and we have real small queues so we don't fall behind. And the queues are just there to kind of manage bursty behavior. But it's really on a use case by use case basis. Some use cases just say drop the data. Some use cases say, hey, I want to have a small buffer to accommodate for bursty traffic. Some of them actually have a sort of a cooperative algorithm where they do a push-pull, where they say, hey, before you even send me any data, I'm going to send a micro-release to you where I say, you send me 100, they send 100, you acknowledge it, sort of like a TCP slow startup curve. And so there's a ton of different strategies depending on the use cases.
And this is all for insights in particular?
For the most part, yeah. We've explored other use cases, but mostly for insights, yes.
Thank you.
For the example you gave for the Mantis jobs, each of those stages, could those run on different machines? Or
they definitely will. And so when you write a stage, the stage has a vertical scaling configuration and has a horizontal scaling configuration, and those are learned over time by our scheduler. So the first time you run a job, you might actually have to bootstrap it with some of that information, but over time, as it's running, our system is adapting and learning about the behavior of the job, looking at those back pressure signals, and then figuring out how to sort of scale it organically over time.
And is there a strategy to branch? Could one stage push to multiple, or would you have to go to a sync that would then?
No, so we do have branching strategies. So you can do like a multicast, unicast, you can do partitioning, you can do collapsing. So we do have different strategies of communication between the stages for a job.
Thank you.
Yep.
Could you please talk a little bit more about Franklin, the metadata storage, and for example, how does that interact with the daily Hadoop job, and how do you do update the meta information?
Yeah, so it's not open sourced right now. It came out when hCatalog was really, really new, and we needed Pig to be able to interact with Hive, and hCatalog just wasn't ready. We tried using it. But in most cases, it either proxies data or it can pass through and say, hey, I want to get this rich metadata into its catalog. And then, as you saw through the Big Data API, you interact with that and say things like giving you all the details on partitions, for example. So an example where it's used is in our Pig pipeline. Because we're in S3 and because of this eventual consistency thing, we use what we call a batch pattern. So we want to make sure that Pig can interact with Hive, and what it does is it never overwrites the same location. Franklin itself will go, okay, well, when you're about to write data, I'll write a new partition, I'll keep the old one around, and when I'm done with my processing, I'll flip them over. So it's a metadata abstraction that you can interact with.
This question is for Kurt. In one of the slides, you mentioned that you're using DynamoDB to solve the eventual consistency problem. But as far as I understand, DynamoDB also has eventual consistency. So could you explain more?
If that's true, then I don't know that that's the case. So can anyone else agree or disagree with that? Like, my understanding is that it is a consistent index within DynamoDB. If it wasn't, the nice thing is it's actually pluggable, so you could change it to any backend you want. But my understanding is that it is a consistent index.
Okay. Then
No, so it's configurable. So from my understanding, you can configure DynamoDB when you're making a read or a write. You can say, I want this write to be more consistent than the default behavior. And so I think for these use cases, we'll probably set that consistency level to a very high level, so you can have good guarantees about it being, there when we query it.
So you use strong writes or?
Yes, yeah.
And I know we do that with Cassandra configurably as well, tunable consistency.
Okay, thanks.
Hi. You mentioned that you have moved over to use the Parquet data format from Arc. Is there a specific reason? Because they both offer very similar functionalities and kind of similar performance improvements. So what was the reason for you to move to Parquet, and what advantages that you found over Arc?
Right, so good question. Actually, we didn't move over from Arc, we moved over from sequence files. So we've been using sequence files forever. For us, it was more a question of what do we choose? And those are both like, what do we do? If we were a pure Hive shop, then we would have gone with Orc. But since we use Pig so heavily and we use Hive, and Orc is really more optimized towards Hive, there's not a lot of traction in the Pig community. It was an easy sort of splitting the difference. So we definitely didn't move from Orc, and when we've talked to other companies and they say that they're a Hive-only shop, we usually say Orc is not a bad choice at all.
Thank you.
Mm-hmm.
Thanks for the talk. I had one question about use of Storm. So basically, could you elaborate some cases where you found Storm was difficult to integrate or implement, and that's why you chose Mantis, or to decide to implement a Mantis?
So I think for us, the biggest difference when we evaluated Storm, Samza, is that they started from the two reasons. So one is that they were sort of designed or built initially with the data center in mind. And the other was that they started from the position of strong guarantees and strong consistency. And so for our use cases, we knew that we wanted to move into the cloud. So the first decision we said we could take Storm, we could take Samza, and we could sort of bolt on some stuff so that it could run in the cloud in our infrastructure. And that's okay, that's fine. But for the second issue is the stronger guarantees and stronger consistencies. We really wanted to sort of trade off and have less consistency and gain more throughput and lower latencies. And that's really a story that's related to us trying to solve insights problems, where we don't have to have strong guarantees about was that data delivered. All we need is a good enough sample to create a signal to know if something good or bad has happened. And we'd actually prefer huge amounts of throughput, low latencies, and losing a portion of the data. From us, for our perspective, that's an okay proposition. And so we looked at Storm and Samza, and we actually met with both the creators and the teams that are working on those, and we talked about what we were doing. And they sort of agreed, from a starting position, it felt like what we were trying to solve was fundamentally a bit different from what these frameworks are trying to solve.
Cool. Thank you.
Yep.
Cool. Thank you. Thank you, Kurt and Justin. So we're done with the morning session. We'll break for lunch now. Lunch is on the 4th floor, so please walk up a floor to get lunch. And we have T-shirts right outside, and we'll meet again at 2. Thanks.